Lesson 3, Partitioning and Creating an Index Organized Table. Part 1, Creating an Index Organized Table. An index organized table keeps its data sorted according to the primary key column values for the table. An index organized table stores its data as if the entire table was stored in an index. Indexes serve two main purposes: to enforce uniqueness when a primary key or unique constraint is created. Oracle creates an index to enforce the uniqueness of the indexed columns. To improve performance when a query can use an index, the performance of the query may dramatically improve. See Chapter 46 for details on the conditions under which a query may use an index. An index organized table allows you to store its entire data in an index. A normal index only stores the indexed columns. An index organized table stores all its columns in the index. To create an index organized table, use the Organization Index clause of the Create Table command, as shown in the following example. In general, an index organized table is most effective when the primary key constitutes a large part of the table's columns. Part 2, Creating a Partition Table. Dividing a table's data in this manner is called partitioning the table. The table that is partitioned is called a partition table, and the parts are called partitions. Partitioning is useful for very large tables. By splitting a large table's rows across multiple smaller partitions, you accomplish several important goals. The performance of queries against the tables may improve because Oracle may have to search only one partition, one part of the table, instead of the entire table to resolve a query. The table may be easier to manage. Because the partition table's data is stored in multiple parts, it may be easier to load and delete data in the partitions than in the large table. Backup and recovery operations may perform better. Because the partitions are smaller than the partition table, you may have more options for backing up and recovering the partitions than you would have for a single large table. To create a partition table, You specify how to set up the partitions of the table's data as part of the create table command. Typically, tables are partitioned by ranges of values, known as range partitioning. To partition the table's records, use the partition by range clause of the create table command. The ranges will determine the values stored in each partition. The TB transactions part table will be partitioned based on the values in the year column. For any years less than 2012, the records will be stored in the partition named Part 1. The Part 1 partition will be stored in the system table space. Any other years will be stored in the Part 2 partition. You do not need to specify a maximum value for the last partition. The max value keyword tells Oracle to use the partition to store any data that could not be stored in the earlier partitions. Part 3, Creating a hash partition. In addition to range partitions, Oracle supports hash partitions. A hash partition determines the physical placement of data by performing a hash function on the values of the partition key. In range partitioning, consecutive values of the partition key are usually stored in the same partition. In hash partitioning, consecutive values of the partition key are not generally stored in the same partition. Hash partitioning distributes a set of records over a greater set of partitions than range partitioning does, potentially decreasing the likelihood for I/O contention. To create a hash partition, use the partition by hash clause in place of the partition by range clause. The number of table spaces specified in the store-in clause does not have to equal the number of partitions. If more partitions than table spaces are specified, the partitions are assigned to the table spaces in a round-robin fashion. You can specify named partitions. In this method, each partition is given a name and a table space, with the option of using an additional lob or vary storage clause. This method gives you more control over the location of the partitions, with the added benefit of letting you specify meaningful names for the partitions. Part 4, List partitioning. You can use list partitions in place of range and hash partitioning. In list partitioning, you tell Oracle all the possible values and designate the partitions into which the corresponding rows should be inserted. Part 5. Creating sub-partitions. You can create sub-partitions, that is, partitions of partitions. You can use sub-partitions to combine all types of partitions, range partitions, list partitions, and hash partitions. For example, you can use hash partitions in combination with range partitions, creating hash partitions of the range partitions. For very large tables, this composite partitioning may be an effective way of separating the data into manageable and tunable divisions. The following example range partitions the TB transactions part table by the year column, and it hash partitions the year partitions by product version values. The TB transactions part table will be range partitioned into two partitions, using the year value ranges specified for the named partitions. Each of those partitions will be hash partitioned on the product version column. Part 6. Indexing partitions. When you create a partition table, you should create an index on the table. The index may be partitioned according to the same range values used to partition the table. In this create index command, no ranges are specified. Instead, the local keyword tells Oracle to create a separate index for each partition of the TB transactions part table. Two partitions were created on TB transactions part. This index will create two separate index partitions, one for each table partition. Because there is one index per partition, the index partitions are local to the partitions. The global clause in this create index command allows you to create a non-partitioned index or to specify ranges for the index values that are different from the ranges for the table partitions. Local indexes may be easier to manage than global indexes, however, global indexes may perform uniqueness checks faster than local, partitioned, indexes perform them. You cannot create global indexes for hash partitions or sub-partitions. Do you want to learn new skills in the fastest and most effective way? Visit learnwithvideotutorials.com.